Today I'm going to talk about the decentralized identifiers and how they will affect the IoT landscape. So my name is Xinxin Fan. I'm head of cryptography at IoTeX. IoTeX actually is a relatively new member in IIC. Currently we have 30 global members in Silicon Valley, China, India, and Singapore. We launched our blockchain platform, the Mainnet Alpha, back to the April this year. And currently we are collaborating with 30 IoT partners to bring their solution to our platform. We have 60 delegates running globally to ensure the safety and security of the blockchain platform. And we have 200K community members actually doing the transactions on the platform. Our ultimate goal is to unlock the potential of what we call the Internet of Trust things on a global scale. To this end, we have this reference architecture, which combines the secure trusted hardware together with our blockchain, as well as secure cloud storage to build the end-to-end trust for the IoT solutions. So in this reference architecture, basically the blockchain is a controller in your systems, and they will orchestrate the cloud storage and secure hardware to ensure your data flow is secure in every stage of the life cycle. We starting build the very fundamental layers above our blockchain. Our blockchain have been fully functioned. You have the fast consensus plus smart contract. And we have a number of decentralized applications on our platform. So the first fundamental product on our blockchain platform will be decentralized identifier. That will answer the question from the industry partners when they bring their IoT solution into our ecosystem, how to represent their device, how to enable their device to talk with the device from another manufacturer, or how to talk to other product within their company. So before we go to the details for decentralized identifier, let's look at what's really the digital identity. As we all know, the internet actually was built without identity layers. When you talk with someone online, you don't know actually who you are talking with. Right? So the digital identity basically is your footprint when you're doing the online activities with different entities. With healthcare company, with your bank, with government, everything you did, the entire activities define who you are. Okay, so in a certain context, for example, when you talk to your healthcare companies, you need to present the identifier, the credentials they provide to you. When you talk to the bank, they know your debit card linked to you. Right? So the identifier have their certain context. However, yeah, in all the identity system we are familiar with, basically can be classified into 3 archetypes. The first one everyone is familiar with is centralized, like IIC registration website, right? They give you the credentials. You only use that credentials to log into the IIC website. That credential only be useful in that context. Okay. The other one is federated. So everyone has a Google email, right? Many service providers, they already use, they allow you use Google email to log into their own service. Like in this case, you get the credentials from Google, and you can get a service from the other providers. Okay. The third category, possibly most people are not so familiar with, is fully decentralized. So the idea here is you receive the credentials from the multiple individual identity providers, like you collect your loyalty card. Right? So for each certain service, you present the different credentials they can trust. So in this case, when you talk to the different service providers, you provide certain set of credentials to access their service. So this is what we said. For centralized identity systems, you create once and only trusted by one. Okay. Federated, create once, and will be trusted by many. Okay. Decentralized identity systems, the ultimate goal is you just create identity once, trusted globally. So all the identity providers form a kind of trust graph. Let's see why people want to use decentralized identifier. That's because the existing solution for identity have the certain limitations. Let's look at we take the email as an example. Everyone uses it almost every day. For the email address, which is a very popular solution when you log into the service provider's applications. Okay. So, however, the email address has the certain properties. First one is has an intended usage. For example, just to send an email to the other party. They may not be suitable to use as identifier in other situations. Also, the email identifiers are correlatable, which means you use your email address when you access the different service providers. They can link you together. Okay. So the third one, also very important one, the email address is administered by the organizations, which can actually take your identity away. If they don't want to provide your service, they revoke your email address, you're screwed. You can never use it again. Okay. Also, the email address has a very limited global resolvability. Some countries use very weird email address, which can only be understood by the certain email server. Okay. Last, the email address are reusable. If you don't you give up your email address, someone can take it. So in certain cases, which means they can impersonate you to access some applications. So we see the existing systems have the certain limitations. Email just one example. You can also think about the other examples in your real world. So we see there's an opportunity. Actually, you can build a secure and decentralized identity hub. So this hub will give you a very unique property, is that individuals can control their identities. That is a very different paradigm you will change to. So this introduced the concept, what's the so-called self-sovereign identity. So the motivation behind this concept is based on the observation that for the current identity systems, the final ownership of the other identities is remain with entities who issue it. Okay. So self-sovereign identity try to change that by deliver a user-centric identity concept. So in this new paradigm, an individual or organization, they can control their own identity. Okay. So currently self-sovereign identity systems, they use blockchain technology as well as legal policies to create what's so-called the self-sovereign, this property. Okay. If anyone not familiar with blockchain, just one sentence. You have a virtual database which are running by multiple parties which are not trust with each other. After a certain round of negotiation, every party can reach agreement. This information will be put into that virtual database. Then everyone know what exactly happened at that certain time instance. Okay, this is just a very brief concept for the blockchain. Okay, I won't go into more details. For the self-sovereign identities, the concept we will explain more here is decentralized identifiers, which is a new type of identifier for verifiable self-sovereign digital identities. So these identifiers will cover all the use cases for individual, for Internet of Things, for organizations. Basically, it's a very broad concept. Try to associate identifiers for all the different type of entities when they bring into the decentralized world. So this specification for the decentralized identifiers developed by the W3C credential group, and you can check the specifications. Although it's not that easy to understand, and the way they describe it is very confusing sometimes. This framework basically just gives you a very high-level framework. It's up to the individual parties to implement for the certain use cases. Okay. DIDs basically have the following important properties. First one is decentralized, which means there's no central registrations to give these identities. And these DIDs will be registered in blockchain or other decentralized networks. It's agnostic with decentralized technology. You can either use blockchain or for your situation, maybe decentralized database, whatever decentralized network you want to use. The other very important property is cryptographically verifiable. Each IDs will be associated with a pair of keys. That key will enable you to prove to the other party, actually, you control that ID. If you have the blockchain wallet, the only thing you can access that fund is you have that private key. Okay. If you lost that key, you lost all your control for the asset. That's the same concept here. For the decentralized identifier, that key is is to represent you are the controller for that identity. The third one is the non-reassignable, which means the DID is permanent, unique, persistent. Okay. Also, DID need to be resolvable to make it useful. What it looks like for a DID? So actually, on the network, you will see something like this. This starts from 3 letters, DID, which means decentralized identifier, and following by a few letters, which is they call the method. Actually, I think it's a little bit confusing here. You can more precisely call it the platform, which means DID can be implemented in multiple platforms, decentralized platforms. So this method or the platform will define how to do the CRUD operations: create, read, update, delete. So each platform will define these these 4 operations to support the DID access. Okay. So after these letters will be alphanumeric strings, which will be guaranteed to be unique within the context of this platform. Many companies working on this. This is just a very short list. You can see in the method column, just different projects. They are trying to implement the decentralized identifiers for the certain applications. They will have the different DID prefix. For the IoTeX blockchain, we will have the DID.io followed by the alphanumeric strings. Okay.
So do you need to register the method?
Yes. So methods, you need to register on the W3C. They will give you associated identifier with you. Okay. So in the blockchain system, what you see just this identifier, which is maintained on the decentralized way. However, this does not mean anything. If you only read this, you don't know what's really behind that identity. So that's why you need to resolve this decentralized identifier. So this resolution process basically just doing a mapping from the DID to the DID document. Okay. So as I mentioned, the method will give you the method how to access your DID document. Okay. So on the IoTeX blockchain, the DID column IO, this method will define all those operations. You don't need to be worried about that. In the high level, all the decentralized infrastructure, you can think it's a global decentralized key value store. This store, you can query for the key, that's your DID, and then they will give you the DID documents. These documents will tell you what this identity is and which function they have. We will look at more specific example later. Also, there is an online DID universal resolver. You can find here. So this resolver, they provide a universal API. So basically, it's like a middle layer between your platform and the user. So user can use their application to access this resolver. This resolver will access your platform to retrieve all the information. Okay, and you can develop the driver for your specific platform. Then based on this, application can easily get the DID documents. Okay, these documents you may not be so familiar, but also as many people in the IoT world, you have been used JSON format for a lot of your applications, right? This DID document basically is a JSON LD document. If you are not familiar what's JSON LD, it's a JSON document with linked data. So the idea for the JSON LD is to enable the machine to better understanding what this document talking about with well-defined vocabularies. Okay. From here, they have the DID document has 6 optional components. Yeah, that's how flexible it is. You have ID here. That's a string you'll see before. You have a list of public keys for different purpose. One public key will be used to show you control this DID document. Okay. They will tell you which authentication method they need to use in order to challenge you whether you know the private key. Okay. Like this case, you need to run a RSA signature authentication protocol with 2018-bit keys. Okay. Also, they provide a set of endpoint. That's your identity. That's where your identity will provide service. Okay. They tell you where to access the service provided by the identity behind this DID. Okay. This service part. Also, they have the field for when this DID document being created and what's the proof, who have been signed these DID documents. Okay. This is roughly structure for the DID documents. Not all the fields are mandatory. It's up to your application to define what you really need. Okay. So with this DID documents, there's the other very important concept here is called verifiable claims. So claims, everyone knows, these verifiable claims basically seal the statements which made by an entity about the subject. I give you a few examples. For example, the government-issued passport will enable the holders to travel between countries. Yeah, the driver license and the university driver license will enable you to drive the car, right? University degrees will be enable you to claim your educational status. All of those are verifiable claims because you can check whether those documents are real or not. Okay. So ideally, all those claims should have these properties. They should be cryptographically secure and respect privacy. Also, they should be automatically verifiable. Okay. You can claim anything and found people to endorse you. However, that needs to be verifiable. Okay. So those are all your claims, how you structure them. So in the DID world, we will structure them using verifiable credentials. Those claims will be used to create those verifiable credentials by the issuers. This document also looks like the DID documents, but still they have the different keywords you can use here. You can see here's the ID, yeah, for this, and the claim say your name is Zhang Dou, right? And who attests that? They will provide the proof here. The creators and their digital signatures. So which means once you receive this document, you see someone already stamp on this name. Okay. Whether you trust this stamp, up to you. That's a very different aspect for the decentralized identifier. So the decision is up to the receiver whether you will trust the credential providers. Okay. Looking at the technology stack for using the self-sovereign identities, usually they have the different layers. The very fundamental layer is the identity owner layer. In this layer, they include all the individuals, the Internet of Things, and the corporations, companies. And you also need to use an agent, especially for people they cannot remember what a private key is, then they will use their cell phone as an agent. And you also have the cloud layer to provide the service, and the blockchain layer to register the decentralized identifier and also to access it. So I gave a few examples here. I won't go into the more details. Some more concrete example to help you to understand how this concept will be used in the future. For example, if I want to apply for the loan, I got my birth certificate from the hospital, and I submitted to the government. they verify this document through the blockchain, and they issue my social security card. Then I talk to the DMV and submit the social security card. I can receive my driver license back. So the bank needs both driver license and the social security card in order to prove my loan. All this, they don't talk to each other. They may have the pre-trust relationship among those entities. All of them go through the blockchain. Okay. This is just one applications. Everyone, in this room may be more familiar with blockchain, with supply chain. So in the future global supply chain scenarios, multiple government and the cross-border regulatory agencies, they will form a group. They will have the pre-established trusted relationships. So when when an international trader want to use a global blockchain to doing the import and export, they basically talk with the exporting cross-border regulator agency to submit their specs for their goods and also their passport. They will be cross-verified through the blockchain, and when the importing CBRA will doing the similar things. So in this case, all the tedious paperwork can be get rid of by forming this type of decentralized architecture. Okay. So what is IoTeX building? So we are actually building this type of architecture specific for the Internet of Things with two goals in our mind. First one, we try to facilitate enterprise customers to realize efficient and effective device management and access control across different business units globally. That's for the enterprise use cases. Also, for our customers, we want to enable them to create trusted IoT data marketplace to share the service with outside world. So we are basically we build this type of platform to enable people to unlock their IoT data to outside world. Okay, so this is basically different manufacturers will have their own smart contract to manage all their own devices. The first batch of devices which are currently will use our identity platform will be 10,000 of IP cameras. We collaborate with manufacturer in China. Also, our own in-house device, which is a trusted IO tracker. It's a tracking device built from secure hardware. It's a Cortex M33 secure processors from the ARM. Also, they have the CryptoCell 330, the security engine from the ARM. So we can use the trust zone technology to build the secure applications on this platform. Okay, this is basically, yes?
For the cameras,
okay.
What's the business model? Is the camera manufacturer your customer?
Yes, they have a few applications you can consider. One is to use decentralized identifier to do the more fine-grained access control when they are using those type of cameras. For example, in your home environment, you can use this type of systems to grant other people, your relatives, to access your streaming video. This is just one case. If this camera using as a surveillance purpose, for example, it's outdoor cameras, possibly you can enable multiple people to unlock their data doing the safety-related monitoring. Yeah, that's maybe two different use cases. Okay, I won't go into details. So in the very high level, our systems basically work in this way. So manufacturers, they either use a cloud CA, or they have their own on-premise certificate authority. So IoT devices will receive the device certificate from all those certificate authorities. Those device certificates, together with device metadata, will go through the manufacturer line. So the manufacturer will create the DID docs on behalf of all those devices. We will provide the dashboard for the manufacturer to host their smart contract. So they basically just upload a bunch of CSV files they can manage their identities by themselves. Manufacturers, because all the manufacturers may be using a different ID. Someone use a UPC code. If it's RFID, they may use EPC code. So you can still use your own identity as a partial of the decentralized identifier. We give the full flexibility for the manufacturers. We provide the tools to help them to create decentralized identifiers, so which will be managed automatically by the smart contract. So yeah, that's basically very high-level architecture for our platform. All of work will be finalized in the next month also. So we are welcome everyone to try it after we release the code and the platform. So we are very open to collaborations. If you think your application really need to either get more efficient device management or the more fine-grained access control, this will be I think it's a good solution to try. Finally, we are expecting we can build decentralized future together.
Okay.
Yeah, thank you very much.
Thank you.